Now we come to mixed combination of cells. Now the combination of cells starts with cells. In most of the cases, what we call this arrangement as conjugate cells. As you can see, both the cells are passing current in the same direction. So the net EMF here should be given as the addition of the two. So it is E1 plus E2 if this is 1 and this is 2. Then we have a second case where we have cells in opposition. Say the cells are connected like this. So in that case, as you can see very clearly, there will be two currents, one going in that direction and the other coming in this direction. So if this is E1 and if this is E2, then we can write the net EMF as difference of E1 and E2. Well, in that case, the current will flow in a direction of the bigger voltage of cells. Say this is 6 volt and this is 8 volt, then the current will flow in this direction as this voltage is greater. If this was 8 and this was 6, then the current would have flown in this direction. So there is no such problem when we say that the cells are conjugate. We tell them that they are conjugate when they are in same direction, and then when we say these are in opposition. So in opposition, we mean to say that they are in two different directions. So these are the two cases when we have cells either conjugate or in opposition. Now, for a case where the cells are like this, or what we say them in parallel, we have to find out that how we can find the equivalent EMF of the cell across these points A and B. Say this is a cell E1 and this is a cell of internal resistance R1. This is a cell E2 and internal resistance R2. Well, now if I have the current, then I can find that this is I1, I can find this is I2, and I can find that this current I is equal to I1 plus I2. So I can go on to write what is I is equal to I1 plus I2. Well, I can see very well that I1 is nothing but E1 by R1. And what is I2? E2 by R2. So from there I can go on to write that this is E1 R2 plus E2 R1 divided by R1 R2. Now what's next? So we have arrived at the current, which we have saying that is E1 R1 plus E2 R2. And from there we have gone on to write E1 R2 plus E2 R1 divided by R1 R2. Now the second part. These two resistances which we had drawn like this and like this are surely in parallel. As you can see very well that they are in parallel because the current have got distributed here. So the equivalent resistance is the product by the sum. So this is what we have, the equivalent resistance. And now the equivalent EMF. So the equivalent EMF is the product of the current and the equivalent resistance. Now if I like the current, it is E1 R2 plus E2 R1 and then divided by R1 R2 into the resistance, which means R1 R2 divided by R1 plus R2. So what I get here ultimately is this kind of a value where we have E1 R2 plus E2 R1 divided by R1 plus R2. So that is the EMF of a cell when we have in parallel. Now they might be of same value also. Say these two are of same value. Then we have no problem. We simply say that the EMF is same across the two cells, as we know that in parallel the terminal voltage is same. So in that case there is no problem. But if the cells have a different EMF, then we have to go for this kind of a calculation. So that is, my dear boy students, calculation for combination of cells. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.